All right. Daily problem. 17th of March, 2026. Oh no. Large. Oh, I'll put timer actually. Timer. 30 minute. Okay. You are given a binary matrix m by n. Okay, m rows and columns. You are allowed to rearrange the columns of the matrix in any order. Wow. Okay. Return the area of the largest submatrix within matrix where every element is 1 after reordering the columns optimally. Okay. So you're looking for like a rectangle with a lot of ones in it. Okay. So like, oh my god. Okay, fine. You can rearrange so you can make the blue column and the yellow column swap, allowing for these ones and these ones to join together to make 4. And that's the best you can do. Okay, that's fun. And then here you can swap, I guess, yellow and... Wait. Yeah. I don't know why they did it like that, but yeah, you could make blue and yellow swap. Sorry, purple and yellow swap to make 3 ones in a row, or you can do it how they did it, which is do some weird thing and eventually get that. Okay. I guess I don't have to think about it as swaps. It's just purely just thinking of the arrangements. How big is the matrix? Okay, so the number of elements in total is 10 to the 5. So you want to be linear in terms of the number of elements. So you want like O of mn time at most, which is fair enough. Wow, people knew what to do. Okay. Um, hmm. I guess trying every combination is probably not the way forwards. Wow, how do you do this? I guess in my mind it's something like oh, wow. Okay, let's just write things down. So 1727, right? Largest submatrix. So in my mind, like you're gonna have a bunch of columns, right? You can kind of think of them as separate columns. Like you don't have to think of them as one matrix. You can think of them as separate columns. And you have n of these columns. So you have n of these columns, each of which have a height of m, right? Like m. So you're like 0, 1, m minus 1, and then like 0, 1, up to n minus 1, right? So like the 0th column, the first column up to the n minus 1th column, and then the 0th element, the first element, and then the m minus 1th element for these dimensions. So if my basic goal is to basically glue as many ones as I can together, I was thinking something like if I can, like let's say just looking at the first example, like looking at the first row, right? There's a 1 here, a 0 here, a 1 here, and a 0 here. Let's say everything else is zeros as well. Then like that would suggest that would make sense to like make this guy here go next to 0. You know what I mean? Like so that the ones are glued. Now, how do I... The fact you can be this efficient makes me think that you can do this efficiently. That's so weird to me. Because, like, yeah, even if the 0 and 2 should be together, like, does that mean the 1 should go across? Or does that mean, like, the 2 should go across and replace the 1? Like, maybe the 0 should jump across all the way over here? Like, you know? Oh, maybe it's about, like... No, that doesn't make sense. Sorry, I was going to say, like, maybe if I take the sum of each column, then, like, that'll give me an indication of, like, which one has the most ones. Oh, bearing in mind, sorry, an idea I could have as well, because it's not necessarily. Oh no, it is. It's a binary matrix. Okay, yeah. So then, yeah, if you take the sum of each column, that would tell me how many ones there are. And then if I take like the sum of each row maybe as well, that might tell me like, okay, let's just take a small example. So let's take the first example. So 0, 0, 1, 1, 1, 1, 1, 0, 1. Okay. So it's a 3 by 3. What did I say? 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 1, 1, and then a 0 in the middle, right? So if I know, for example, that like, okay, this adds up to 2, this adds up to 1, this adds up to 3, this adds up to 1, this adds up to 3, this adds up to 2, right? Bearing in mind, I think these numbers are always fixed, right? Because if you're only rearranging columns, the rows are going to have the same number of ones everywhere. So this is always fixed. Like, regardless of how you swap this around, the top row is always going to have a 1 in it. Yeah, the second row will always have 3 ones, and the third row will have 2 ones in it. So that's maybe the row something is not as important. Maybe it still could work, be useful. I'm not sure. But I don't know why I did that. Like, if I see that, look, this has a 2 and this is a 3, so like maybe they should be close together. Um, 0, 0, 1. These two go together, the 1 stays. I'm trying to figure out, like, if I can figure out that there's a 0 here from the fact that there's a 1 here, you know? I guess the fact that there's a 3 here and there's a 1 here tells me that the 1, there's definitely a 1 here kind of thing. I feel like I'm playing Sudoku or something. Like, I don't know what's going on. Maybe I'll take another example. I think this is like too many ones at once. Let me just make a non-square example. Let's say 3 rows and like 5 columns. 2, 3, 4, 5. 5. And then let's say like 0, 1, 1, 0. Maybe 1 over here, 1 over here, a couple of zeros. 1 over here, 0, 0, 0, 0. One. Maybe, I just realized I feel like I made the best solution straight away. I don't think there was any swaps I could do. Let's say there's a 1 here. Is that any better? Ah, wait, yeah, this is what I want. I want to find how many, like, what, like, island blocks there are. Like, hang on. So, like, if I can recognize that there's a 2 thing here, and that maybe there's like a thing like this, and there's like a thing like this, right? I want to find all the vertical 1 blocks. If I can figure that out, then I can look through each row and ask the question, well, um, maybe this isn't as helpful. Ooh. Like I noticed that these three, for example, sort of occupy the same row. So I think, okay, if I join you three together, then that's pretty cool. Versus like these two kind of are on the same row. So if I join these two together, that's pretty good. So that I end up with something like, one on the bottom, one on the bottom, oops, and then like one on the top, and then like one. Like something about knowing where like the nice puzzle pieces are or something. Um, I just feel, whoops, that's fine. Um, I don't know. Damn, hate being this stuck. I guess like let's say I'm trying to figure out if I'm allowed to be like super greedy. I assume I can't because there could be so many like combinations of columns that like I feel like taking a greedy approach wouldn't make sense. But like for example, if I immediately recognize that, let's say this one and this one would make like this kind of L shape if I was to do the correct swap, right? Would I recognize that that's like somehow optimal? Like having this guy here rather than having this column is good. So I'll like swap them kind of thing. Um, but is that too greedy an approach to like, especially considering I'd be separating this one from this one, which could also be problematic. But then again, if you can join to you, then you can still join to you. Like there's nothing stopping you from also coming along for the ride. Um, hmm. I just feel like because I'm taking small enough examples, it seems like relatively okay. But as soon as it gets big, I'm gonna have problems with like all the different sort of possible good moves, all the possible improving swaps that may not necessarily be optimal swaps or something. 1 1 0 1 1 1 0, a 1 down here, 0 1 1 0 0 1 0 0 0 0 0 0 0 1 maybe 0 0 0 0 0. Okay, so taking the same kind of plan, mark out the boxes, the vertical boxes that are like all ones in each column. I imagine I've already used like half my time. I can't believe this is a medium problem. Am I really that silly? Okay, so I'm looking for columns where they share like the same kind of row ones. So like I see you, and you are all quite good. So I could link you three together. Make a three kind of thing. Um, oh, no. Does that work? Wait. I have an idea, but it's kind of dumb. I think the row sums are good. I know that there are three zeros. I know there's no zeros here. I know there's three ones here, right? So I look up where the ones are and I ask, okay, if I was to glue you guys together, you, and you, what's the biggest thing I could make? And the answer is, well, three, because I'd make like a row, like I'd make a thing like this. by making 0, 1, and 3 glue together. I look over here, I see a sum of 2, and I ask, okay, if I take the two guys that are here, you and you, and I glue you together, what's the best I can make? Well, the answer is 2, right? But you two. This might work. I'm not sure. Then this has a sum of 1, which means the best I can make starting with you is 1. The sum here is 2, which means the best I can make would be gluing you and you together, which would give me 2. Oh, this might genuinely work. This has a sum of 2 as well. The best I can do is gluing you and you together, which gives me 2. So I return the minimum, which would be u3. So it's gluing this guy, and this guy together. 0, 1, and 3, putting them together. I think that works. So it's like figuring out these sums is O of mn. Finding all these blocks would be like O of mn, I guess, because like you'll be iterating down for each row. And this final iteration, oh man. Okay, I have a plan. The plan is stupid. First things first, I think I'm going to make a copy of the matrix. And that's how I'm going to keep track of where all these 1 blocks are. How much time do I have? Okay, I literally use half the time. Good job. Man. What do I want to do? Okay. Okay, this is going to make 0 sense, but the 1 blocks is equal to matrix at row RC for C in range noncols. Oops, I messed up. For R in range num rows. And then num rows is equal to the length of matrix, and num cols is equal to the length of matrix at 0. Okay. So I think I've made a copy. Then what I'm going to do is I'm going to, okay, so I'll take the same example and redraw it so I can explain what I'm going to do. So, need more space, come on. Okay, come on, there you go. So, my copy is going to look like 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, and 7, and 4. 2, 3, and 4. So originally, by the initialization, it will look like 0, 1, 0, 1, 1, 0, 1, then 0, 1, 0, 0, 1, 0, oh, wow, 0, 0, 0, 0, 0, 0, 1, 1, 0, 1, 0, 1, and 0, 0, 0. Okay, so that's what it looks like. What I'm going to do is I'm going to say, okay, look, we're going to start from the bottom and work upwards. Okay, so for each column, start from the bottom and work upwards. If there's nothing beneath you, then continue. Otherwise, if the previous guy is non-zero, then add 1, else continue. If the previous guy is non-zero, add 1 from this guy, else else continue. Now, for example, if the previous guy is non-zero, and you are a 1, then take the previous guy, add 1 to it, and make you that. If the previous guy is okay, it's not. If the previous, and it's not. Start again, bing, 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 bing. So this will stay as a 1, but this will become a 2. Because the previous guy is non-zero, you are non-zero, so take the previous guy, add 1, and make you that. So you become 2, you become 3. So the previous, just to explain that, previous guy is non-zero, previous being like below. Previous guy is non-zero, and you are non-zero, so you become 2. Previous guy was non-zero, and you are non-zero, so you become 2 plus 1, which is 3. You are just a 1, and then you are just a 1. So what am I doing? I'm basically indicating, look, in this position, at this block, at this cell, there are 2 1s. That's what this is saying. There are 2 1s, as in the original array. There are 2 1s here. You know, over here, I'm saying there are 3 1s, here down to here. Okay, so in general, what did I just say? So for each row, I said, no, for each column, for col in range num cols, for row in range, we start at num rows minus 1, like we start at the bottommost row, go down to 0, so minus 1 exclusive. If row is equal to num rows minus 1, like we're on the bottommost row, then just continue, we can't do anything. Otherwise, if matrix at row plus at the beneath row same column is greater than 0, and you matrix at row col are equal to 1 basically, then you matrix, no, not matrix, oh no, this is fine actually, 1 blocks at row column is equal to 1 blocks at row plus 1, like row 1 row down, column, that guy, plus 1. Okay, I'm pretty sure that this will give me this kind of matrix, where it tells me at a particular point if you are non-zero, how many cells beneath you are non-zero as well as you. What is the height of the 1 block starting with you? Right? This is a 1 block of height 2. This is a 1 block of height 2. This is a 1 block of height 3. This is a 1 block of height 1. That's my goal. I'm also going to have the row sums, so row sum equals, can I do this cleverly? So it's the sum of each, wait, what? It's the sum of each row for row in matrix. So this will get me these numbers on the side. The 3, like adding the 3 1s together makes the 3. Adding the 2 1s together makes the 2. Adding the 1 by itself makes the 1. Like that. That is what that's meant to do. I have 6 minutes left. Fantastic. I still don't really know what I want to do. Okay. Then the final piece of the puzzle. For each row, iterate through the 1 blocks and figure out how many, maybe I don't need the row something if I'm going to iterate anyway, but iterate through each column, figure out, yeah, okay, I think this is going to work. For each row, so for row in range 0 up to num rows, for col in range num cols, right? So I'm actually going to be using 1 blocks now. So I'm going to say, okay, get all the if the 1 blocks at row col is greater than 0, that means we have a 1 block. Then what I want to do, so like this is a 1 and then there's a 2. Oh, I know what to do. I know what to do. Num blocks is equal to 0, like the total number. So num blocks should increment, and then the min height we'll just say is equal to 1. So, or no, min height is float of infinity actually, and then min height is equal to the minimum between the current min height and the one block's value, right? You do that, and then the max, so the area of this, of joining these guys together will be the min height given multiplied by the number of blocks. So if no blocks get found, it'll go to 0, which is what we want. And then best area, max area, max area is equal to, we'll say 0, that's fine. No, wait, I need to do this after I run through the entire row. Oh, I'm scared. Max area is equal to the maximum between max area and area. I guess I could just do this, hey. Whoops, do this. But I'd rather have it separate for now. Okay. For each of those. Am I done? Did I do it? Return max area? This feels like so I didn't end up using this actually. I didn't need that at all. That kind of makes sense. I don't know. The proof isn't very clear in my head. It's a bit like I don't know. It's like because my idea is basically, look, if you focus on like this row, then you've got a 2 block, a 2 by 1 block, right? And then you got a bunch of zeros. So it will know that there's a 2 block and there's one of them. The minimum height was 2 and there's one of them. Yeah. Should min height be max like infinity? Surely, right? Because I want to be minimizing. Yeah, I want to pick the minimum value. So yeah, 2. And then when we get to this row, this is the beauty of this array, is like, I know at this point I have a 1 block. And then I have a 3 block, right? But, you know, in the mind of this guy, this might as well just be a 1 block as well. You know, it might as well be just one person because this guy only has 1 anyway. So the min height of gluing these two guys together is 1, right? The natural height of the matrix that we get is 1 when we bring these two guys together. So min height is 1, but there's 2 blocks, so 1 by 2. I honestly think I might have done it with 2 minutes to spare as well. I don't know. I think I wrote it okay. Let's just see. Oh, damn. Let me print 1 blocks after we run all this. I'll be really sad if the logic is wrong. If it's like I just made a mistake programming, that's okay, fine. But if it's genuine, like, okay, so in terms of the original, 003, 212, 1. Okay, so it seems like that has done what I expected, and it still got it wrong. Let me simulate. So we have, so this is the original. This is actually the very first example. It's a 3 by 3 from memory. So 0, 0, 1, 0 in the middle. What's the middle row? All ones, right? Okay, and then yeah, like we said, the num blocks, the 1 blocks array will be 0, 2, 1, 0, 1, 0, 3, 2, and 1, right? So in my mind, what I thought was, okay, oh, I see what's happened. It's like okay, I see what's happened. So I was basically greedy. I told myself not to be, but I did greedy basically. It saw the 3 by itself and thought, okay, if I focus on this row, the area here is 3. If we focus on this row, it sees a 1 and a 1. The best area is 2. Unfortunately, what happened here was it saw a 2. It saw a, I'll do it different colors. It saw a 2. it saw another 2, and it saw a 1. And the only instructions I gave it was to glue all the 1 blocks together. The 2 block, the 2 block, and the 1 block. So that made it go to 3, right? But there's a better way by ignoring this green block and just gluing the 2 blue blocks together to make 4. So if you're going to make the height smaller, the min height smaller by introducing a new block, the question is it worth it? And I think, how do I decide that? Maybe I can sort it. I can be like, I can sort them by heights or something. Like, I don't know if this is getting a bit too much now, but I think I'll get away with it. O of mn log mn kind of thing. I sort the heights. So I know it's 2, and I know it's 2, and then I know it's 1. And I ask, okay, what's better? Is it better to, I iterate through these, and I ask, okay, I have a 2, and then a 2, which gives me 2 by 2, gives me 4, or I have 2, 2, 1, which would give me 1 by 3, which gives me 3. And so I would keep with this one. I would stick with this one. And then I would, but there might be like another 2 1s, for example, or something. So then eventually it gets to 5, 1, 2, 3, 4, 5, which is better than the 2 by 2. So like it becomes 1 by 5 equals 5, and that becomes the best kind of thing. So you're basically just taking the maximum across all of these sort of possibilities. Like, do I take the first row by it? Do I take the first block by itself? Do I take the first 2 blocks, the first 3 blocks, the first 4 blocks? Okay. Let me try that. So I'll do 2 iterations through each. So I'll say 1 blocks in the row is equal to nothing. For column, so first things first, I'll say 1 blocks in the row dot append 1 blocks at row and column. I have run out of time. I registered that. I will work on this for another 10 minutes and see if I can get it right. So we have all of this. Then I will sort 1 blocks in row dot sort with reverse equals true. So I'm prioritizing getting the tallest 1 blocks first. And then for 1 block in the 1 blocks in the row, and then like, yeah, possible areas is equal to areas is equal to this. And then for 1 block in 1 block in the row, note that the minimum height is going to be equal to OB because we've sorted OB to go descending. In enumerate, min height is it the number of blocks at the moment would be I plus 1, where I is the index that we're up to. If we're at index 0, that means we are up to 1 block. And so possible areas dot append min height times num blocks. I don't really need an array here. I could just be like best area for the row is equal to 0. And then best area for the row is equal to the maximum between the current best area for the row and min height times num blocks. And then the max area is the best area for the row, which might use all the blocks in the row, might use only some of them. hopefully. Um, I think that's better. I don't like that I had to sort, but it does work. Do I shoot it or do I try to do some more testing? Maybe I'll cheat a little bit just in the interest of time. I'll see if anyone else has put tests in. Okay. Thank you. This guy's actually like quite the goat. He's here a lot. No, everyone else was calm. No one else put test cases. Fair enough. Yep. There's that site, right? Oh, what? Oh, I didn't realize. Copy, paste. Oh, what? Oh. Well, I guess I can just do it for this much. I don't know. I don't know. I mean, like, I think logically speaking, I think it does make sense. I just don't know if it's too slow. And let me do a time context. I think the code is fine. Also, won't print this because I might get output error. Okay, num blocks. So I back the one blocks thing. I back that makes sense. For each row, num blocks is equal to 0. Like, how many blocks are there? I actually don't need this anymore, do I? Do I even use this variable? I defined it there, so yeah, I'll get rid of that. Min height. Same thing here. I don't think I need this either. Yeah. Okay, so one block's in the row. For column, append, make a list of all the... I might even be able to do list compression or whatever it's called instead of doing a for loop, but I'll first make sure this is correct before I do that. So yeah, prioritize the big blocks first, the tall blocks first. Best area starts at 0, and then you maybe I would call it OB. That's a bit of a weird name. Current one block. I current one block in the one blocks in the row. Min height is that current one block. Number of blocks is I plus 1. Okay, I send it because I think I don't know where it'll go wrong. It might go wrong. I'm scared. Yeah. Oh wow, it's slow. Well, at least I had an idea, and I wasn't that slow. It was like an extra 10 minutes or something. But as in the code is slow, but my brain wasn't that slow. And then I just want to see if I can quickly make this. So I'm trying to get one blocks in row is equal to I want all the values in one blocks at row col for col in range num cols if one blocks row col is greater than 0. I think you can do that. I'm like pretty sure that's legal. So I don't need this for loop and I don't need this guy. Yeah. I don't think it'll actually improve speed or anything. It's just more for cleanliness. Fantastic. I mean, it will increase speed a little bit, I guess, because less memory allocations, but... do I want to cheat straight away, or do I want to see if I can figure out what you could do better? Honestly, I don't think my brain could do anything more than this. Like, I know my limits, and I think this is the only annoying part. The fact that I saw it. But, like... Yeah, like having the OM log OM... Sorry, O of MN log MN. Like, the log part is what kind of thing screws me. Having to sort it. But is there anything better I could do? One blocks in row, one blocks row call for call. Yeah, okay. So you extract out all of the one blocks basically. which I think you'd have to do. Like, I don't know what more you could really do in that situation. The one blocks in the row, instead of sorting, is there anything else you could do? Maybe you could, nah, sorting's too clean. I don't know what else you could do. It's too right, you know? It's too, like, helpful to sort in that situation. Oh, wow. MK. So we're looking at, I'm not looking at like the absolute fastest, I'm just looking at the mode. So MN classic, answer is 0, fine. For R in range, row 1 up to M. So you're ignoring row 0 and you're going straight to row 1. For C, for each column, for all the columns though. So, okay, rows from 1 up to the last one, not taking the row 0. If it's equal to 1, then matrix row C plus equals the previous. Ah, so they went like a normal direction. They went like down instead of up. I went up for some reason. Sort each row. Oh, you do sort. I mean, their code is a lot shorter, which means what do they do? Ah, they didn't make an extra copy. They just true actually. Did I ever use matrix again after I did, did I ever use matrix again after I did this, and then I did this? If I replace one blocks, which is that array name 1, 2, 3, 4, 5, 6, 7, 8. If I replace all of them with just matrix and get rid of the construction of one blocks, so I don't need that. Let me just see if that runs. No. Oh, it must be something weird. Yeah, this is the issue. So if row plus 1 is greater than 0 and you are equal to 0, then make you bigger. I'm surprised the first 3 test cases passed, considering that. Oh man. Sorry, greater than 0, greater than 0. Not greater than 1. Okay. Is that it? Would that be the only issue? I mean, reconstructing the whole n by n array would be problematic. Oh. Wait, let me just compare. Submissions. It did save time, but it's not the major issue. Well, there's other issues at least. I feel like this is pretty much the same as what I did. I could be wrong, but this idea of like, yeah, you've got the number of rows, number of columns. Obviously, yeah, they went row by row though. That's interesting. But I guess it wouldn't really make a difference so long as you're hitting all the elements. It would be fine. Yeah, that makes, yeah, I probably didn't need to, I could have, yeah, okay, fine. I realize why that going from 1 to M is better than having a continuous statement. That's fair enough. For R in range M though, yeah, so same thing here. Row heights, matrix. Ah, he does sort it straight away. That could be a thing. That could, I plus 1 is that num blocks thing. Row heights is the min height, right? And then answers max. It does feel like they're very similar. So I would think that maybe it is this. And I assume reverse equals true, or yeah. Actually, no, this wouldn't make a difference, would it? Not really, right? Because in my head, for some reason, I was thinking like by doing it this way, um, oh, true, because I'm using the same, I can just say matrix R, I guess, and I'm sorting, so all the zeros go to the back. Okay, let me just try this just to see if it does anything better. Yeah, so this comprehension is actually kind of useless. Matrix at this row sorted. I don't need the outer brackets. Just make sure there's no issues. Yeah, wow. Yeah, I don't know. I don't think I'm doing anything that crazy different to the mode. I'm just gonna leave it as like a leak code being fun, rather than me being stupid. I mean, maybe I've got a few extra redundant assignments and stuff, but that can't be making that much of a difference. Like I could, instead of saying num blocks, I could say I plus one. You know, like I could do stuff like that. But like, whatever. Okay, if that's the difference between me and the mode, I'm not that mad. Like, 'cause I think code wise, it's pretty much the same. And then what did the crazy people do? Similar, just probably cleaner writing. Maybe yeah. Wait, you could do it in one for loop because if you go because you're doing rows, yeah. There's maybe yeah. Okay, that kind of makes that's pretty cool actually. Doing it in one for loop if you go by row because I was thinking of constructing the one block array with columns. I didn't like unify those for loops, but yeah, you could. Okay, well that's not bad. That's a good problem. I think. Like I took a bit of thinking, but we got there and a bit more than half an hour. All right.